Welcome all on our webinar. Today, we will speak about leveraging large language model for enterprise usage. Today with us, Zenobia Charpy, the senior deep learning data scientist at NVIDIA. And I give to her a microphone.
Yeah. Hello, everyone. So we're a bit late. Let me share my screen to the full screen. Do tell me that you can see full screen, right?
Yeah.
Good. So, so welcome again, and thank you so much in participating and listening. Today, we're going to talk about large language models for enterprise usage. So my name is Zenobia Charpy. I'm a senior deep learning data scientist working at NVIDIA. My focus and specialty is at training, deploying, and customizing large language models in generative AI use cases target at enterprise usage. So today, the way that I would like to go through this webinar is as following. First, we're going to talk about trends in generative AI landscape. Hopefully, we will get some question answered. And then we are going to look at a few selected use cases. From that point onwards, we're going to distinguish what's the difference between foundation models, LLM, ChatGPT-style models. Afterwards, we're going to look at, well, because I'm from NVIDIA, so we would definitely look at what NVIDIA can provide when it comes to generative AI and LLM. So what are we doing in this landscape? Now, you guys probably have already been exposed to ChatGPT and probably have used quite a few times. Now, these type of models can sometimes hallucinate and or give you factual incorrect answers. So we're going to look at how to mitigate these type of questions, so that we can actually control the conversational flow, set guardrail around in order to, in the real use case scenario, right? Okay, so we are a little bit late. So without further ado, let's dive into it, shall we? If we look at the circles, the yellow circle from inside all the way to outside, we can see that this is basically how fast these technology will impact you and your business. Now, if you're looking at all of those little dots, these are the technology with low to high mass, as in how impactful they are. I'd like you to pay attention to 3 of those technology. That's what we're going to talk about today. First one is foundation models. They are also known as large language model, LLMs. Sometimes they are interchangeable in many different scenarios, foundation models and LLMs, but they do have some sort of differences. You can see that it is directly in the outskirt of the yellow, which is 0 to 1 years, which means that this technology will impact us fairly soon. Okay. Next up, generative AI. In the next slide, we will be looking at what are the models in generative AI as is now, as well as the applications. However, we can see that this is in the time span of 3 to 6 years. In the edge of the outskirt is responsive AI. This will be the last section we touch on of the way that we try to, this is the beginning of the journey, right? Nobody has the right answer. So it's a way that we, NVIDIA, are trying to give you tool sets where you could customize and be responsible, complying to policy, complying to laws, and in any way possible, but you need to do this in the iterative process. Okay. Again, we will have these 3 technology, the one we're going to talk about and focus on today. And then some of them will impact us much more sooner than the others. But let's take that step. When it comes to generative AI models, there are kind of a lot of different multimodality models. You have the text, you have the code, you have image, speech, video, 3D, and so on. Now, as you can see, and later on we will find out that there are more models in this space as well as the applications, followed by code as close and image as close second. And the rest of the others are, well, can say developing. And this hunch or feeling that we're having is actually not too far off. So we are at year 2023 now, already past half of the year. But as we can see, that text and code, when it comes to all of this generative AI technology, remember in the first slide, which we already seeing these technology will impact us. We just don't know how fast and how strong. Now we can see that text, well, in that sense, foundation models and the continuity of the foundation models, we're going to talk about that soon, but we're going to put a pin on it right now. They're going to impact us. And some of those technology are much more mature than the others. So text is one. They are ready in the prime time for you to plug and leverage this technology into use cases. Okay? So that naturally lead us into what can those text-based language model do? Right? Let's take a look at a few use cases. Now, before we do that, we first need to understand how can we interact with these models. Inferencing with large language models. First, you will need prompt. And on the left-hand side, you can see this is a question and answer task. More specifically, it is a one-shot, as in it gives a question and answer pair. So that's one example, one shot of example. And then you ask the real question. Then this entirety of the input prompt will be passing through the large language model to get the response as completion. There's a lot of things you can tweak when you are making inferencing with the language models. There are many parameters, such as the number of token you wanted to generate, bin size, temperature, and so on. That's also known, in a closed door way that we say temperature is sort of like creativity. How creative do you want your model to think outside the box and not stay of what you are asking? For example, if you set the temperature high, maybe we'll answer something completely different than what you are asking, right? And so on. There are quite a few of parameters we need to tweak. However, once this model are tweaked and aligned to human preferences, we don't need to do those things anymore. We just need to set an instruction. They are ChatGPT-style models. So now before we are getting ahead of ourselves, we're going to come back to that, but let's take a look at the use cases in the enterprise scenario. First up, co-authoring with language models. Whether that's composing emails automatically for you, and then you can just edit it, generating stories, or blog posts. Now, these are all valid use cases that enterprise can leverage directly with even foundation models, because these are generative type of models. Okay? They can generate new things for you based on whatever that you are putting into the as prompt. Next, personal tutor, chatbot, customer care. We can have an interface where we plug in large language model as the core to serve as a service, interacting with real human in many different packaged scenario. Sometimes we might add recommender system on top of it. In many of those scenarios, you must do that. And here are companies, startup companies. They were leveraging the core of large language model technology specifically to get money, So these are real legitimate use cases that enterprise can consider to leverage, to use in your everyday work. Moving on, a more novel use case. Now, what if, think about it, what if that we trained the large language model not on the natural text, but on music tokens? So in the training time, we are going to take the audio pre-process into music tokens, such as those ones, right? And in the inferencing runtime, we can specify, for example, here the instrument is drum. Then we will ask you to continue to generate more tokens, drum tokens. And then we can put it in a synthesizer and listen to the drum that's generated. So you can actually co-compose with these models. Let's have a listen. Now, similarly, if you trained the large language models on structured, comma-separated data in the inferencing runtime, you could ask it to generate more synthetic data. So how is it useful, you ask? Well, if you have sensitive information such as, employed salary or their personal number with the tax income, whatever, those sensitive information you might want to anonymize those people. You might not want it to actually show up, but you do want to do analysis on it. Even these kind of things, even difficult to share between employers, employee departments, and so on. Then why not create synthetic data for enrich the data? Some of those data are like very scarce and very little that you could insert the outliers, right? You can ask it to generate as much data as possible. So in that sense, you could actually use it and trim it and filter it to do analysis from. Next up, and the last use case we have is co-piloting, co-generation with, so on the right-hand side, you will see the code generated, and then you basically copy and paste this code using ChatGPT into Omniverse. Omniverse is an NVIDIA technology that allow you to create 3D models. So let's have a look at that very interesting use case.
Check this out. You are an expert Omniverse developer. So I gave ChatGPT that command, and I basically asked it to make me a window that can make spheres appear and vanish. It made me this code, and check this out. I'm going to run this, baby. It's have this magic spheratron. Let's look at my stage while we do this. Create a ball. Boom, 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 boom. I can hit as many as I want. Okay, that's cool. Not bad. Magic spheratron. Let's make them vanish. It will erase them in order. Create, erase. Pretty damn cool. And this is actually ChatGPT that helped me do this.
Right, so we're now seeing a few of interesting use cases that enterprise can perhaps consider leverage into their everyday usage. Remember, we put a pin on, clarifying what's the difference between foundation models and ChatGPT-style models. Let's go back and have a look. So, foundation models are trained on unsupervisedly, trained on large corpuses like terabytes of data, right? Unsupervisedly. However, when you want these foundation models to follow instructions, then you must use annotated data, so supervised fine-tuning into SFT supervised fine-tuned models right here, right? But we have to start somewhere. I mean, ChatGPT-style model has already gone through this entirety that you have seen in this slide, right? But we have to start somewhere. So we're going to talk about foundation models first. That will lead me to what are we doing at NVIDIA? So at NVIDIA, we have two things, as you can see. There are two blobs here. You have the AI foundations. They're offering foundation models. Remember, we just talked about foundation models. They are not tweaked or fine-tuned toward aligned with human preferences. So those foundation models, they came in different ways, right? You have the one called NeMo Service. These foundation models is trained on natural language data, right? And a lot of them. Then you have NVIDIA BioNeMo Service. These type of models is trained on chemical molecules and protein sequence data, right? So they are specialized. You see, previously when we see this kind of novel use cases in co-composed music, if you train language model with the same technology. However, if you train this model on different modality of the data or different type of data, you will get a completely different kind of way to interact with it, right? So the same thing happened with this. We also have NVIDIA Picasso servers, so we train diffusion model from scratch in order to ensure these data that we train on are enterprise licensing compliant. So you will not have a problem in the sense that, if you say these data sources are problematic, my legal department will not approve. We can basically train from scratch a diffusion model specifically for that. Okay. Now, if you say that, okay, these foundation models with some parameter efficient capability to customize, if they are not enough and then you came to the conclusion that, you know what, I'm going to train my own foundation model for my own business, then we will be talking about how an open sourced NVIDIA NeMo framework can help you. But first, due to the interest of time, I'm only going to touch on this one, the NeMo service first, and then we're going to talk about the NeMo framework. Okay. So what is NeMo LLM Service? What are we offering? So here's what we offer. We have, the normal playground user interface, the curl Python API command, so that you basically can integrate it into your own applications. We also provide customization technique. For the moment, there's only two, but there's more to come. First is p-tuning technique. As you can probably see, and I hope the screen is big enough, here is a command of turn off any morning alarm after Friday. So after you p-tune a foundation model, so you will have the ability to extract intent, alarm remove, slot, time, morning, date, Friday. Okay. So p-tuning is one of these parameter efficient fine-tuning technique. When you have a large foundational model, they are usually like checkpoint is like terabytes to save the disk. Then you just want to tweak a tiny part of it just to be able to do one very crucial task that's business dependent. Then you can use parameter efficient techniques such as p-tuning and a lot of others to come, like adapters, LoRa, QLoRa, and so on. So you can use customization to tweak your foundation models in order to serve a specific purpose. So retrieval knowledge base is also one of these, where you can equip the language model with proprietary databases informations that is not open for the public. It is made to scale so that even though that you have large databases across different continents even, it is possible to do this with scale, okay? To equip your language model with this novel knowledge that's proprietary, that's sensitive, that's on-prem to the language models so that it will understand and being able to quote from those proprietary data and stay, hopefully, factual to it. Okay? Okay, so now we have talked about NeMo LLM Service, which is basically our way of we opened our foundation model for people who had access to it. Now it's in early access state in order to leverage those models that we train. Now, if you say I have come to the conclusion that I would like to train my own foundation models, remember we talk about foundation models here. So NeMo framework is an SDK, right? It can help you if you want to train one from scratch, or if you want to take a foundation model, let's say Llama 2 from Hugging Face, and then you want to further supervise fine tune because you do collect your own high quality annotated data set and you want to supervise fine tune it. Or you want to go through because you have people already interacting with these models and you collect, how well this model is doing, and then you can build your reward functions and you want to get to a ChatGPT-style model. NeMo framework support all of it. Okay. In order to train a foundation models, so assuming that you want to train your own foundation models, you will need these things. You will need gigantic amount of data. You will need to have access to large compute instances, whether that's on-prem or in the cloud or hybrid. Then you will need a framework that can leverage the underlying compute and absorb large amount of data in order to train and finish in time. And of course, you will need collaboration in case something goes wrong. Then you will need guidances and advice, right? So NeMo framework is such a thing that will be able to leverage the underlying compute, whether that's in the cloud or an on-prem supercompute compute instances, what we call superpods. NeMo framework will be able to help you leverage these underlying compute to process terabytes of data. So it comes with the data curation module to help you clean the data to get to the point where your data is like, if it has a lot of HTML code or if it has a multilingual languages, but you only just want one or two and so on. And then once you got your data set cleaned, it will help you to do distributed training with 3D parallelization technique, such as data, tensor, pipeline, sequence parallelism, and selected activation recomputation. These are all techniques that is known for, such as deep speed. Also use some of these techniques in order to scale, partition the model into thousands of GPU in order to train gigantic large language models, right? Currently, we do support these type of language models. So you can train encoder type of BERT models up to 100 billion. We support T5 encoder decoder model with mixture of expert, vanilla T5, or GPT-3 autoregressive model that is usually known. And Inform, which is retrieval augmented model, which we just gone through. It also, in the future, will extend to multimodality supporting vision models, such as Stable Diffusion, and Edify is our own diffusion models, Vision Transformer, and so on. Now, NeMo framework is a full stack framework that take you end to end. It's not just helping you to do training, it helps you to make inference as well right here. So once you got a model that you're satisfied with and you would like to make inference, now I'm not talking about like inference like one person at one time and the second person will have to wait and so on. So you have to be in the queue. I'm talking about inference at scale. It will scale as your use spaces, as your query scale, right? So it's purposely built to scale both in training as well as inferencing. Okay. Now, let's say you get a foundational model that you're happy with, and then they are trained on natural language. How about that's, if you consider the language model as a brain, right? Instead of interacting with it with typing, how about we add a voice to it? So imagine a person is speaking, We're using a speech-to-text model, automatic speech recognition model, which we also have from Riva, another SDK we have, to transcribe the text. And this text will be digested with language model, the foundation model. And then the completion, the response, will be, again, use another Riva text-to-speech model as voice. Let's take a look at a demo about this.
New York City has which 5 boroughs?
New York City has 5 boroughs: Manhattan, Brooklyn, Queens, Staten Island, and the Bronx.
How is the weather in Manhattan?
It is sunny in Manhattan at the moment. The temperature is 54 degrees Fahrenheit, the humidity is 50%, and the wind speed is 14 miles per hour.
How about 54 degree Fahrenheit to Celsius?
54 degrees Fahrenheit is 12 degrees Celsius.
Right. So if we don't stop there, again, consider your language model as the brain. Now we have already add a voice to it. How about we add both a voice and a face to that brain? Now, before we go into another demo, let's take a look at how is that possible. So we have the NVIDIA Avatar Cloud Engine that will help you make avatars. And you probably have already seen a bunch of those in NVIDIA technology blog, as well as our GTC conferences. Under the hood is using a unified compute framework. So it's like low coding, drag and drop to connect different modalities as well as those points in order to make sure you can equip the language model with the voice and the brain. So the result is this.
Tell me a story.
Alice had always been a punctual person. She made sure she was always on time for her piano lessons, and she had never been late before.
What's next?
But on this particular day, she overslept and was running behind schedule. In her rush to get to her class, she didn't notice the manhole cover in front of her until it was too late. With a startled yelp, she fell through the opening and plunged into darkness.
That's interesting. Tell me more.
As she landed on a pile of dark feathers, she realized that she was no longer in her familiar world. Instead, she found herself in a dimly lit tunnel with gleaming brass and intricate gears that seemed to stretch on forever. As she tried to get her bearings, a strange creature appeared before her.
Oh,
It was Packer the rat, a rat with big green eyes that looked like a rabbit, with shiny steampunk goggles perched on his head. Packer explained that Alice had fallen into a secret elevator that transported her to a land of wonders, a place called the Steampunk Underground.
that's so cool.
Alice was skeptical. Then Packer said they needed to go on a quest to save the captive King of Spades, who has the key to get back to Alice's world, along with the other imprisoned cards to free the city from the evil Red Queen. Alice was hesitant, but she realized that this was her only chance to return home. She agreed to help Packer in his quest to rescue the King of Spades and free creatures from the tyrannical rule of the Red Queen.
Oh, I wish you the best. What's next?
With a wave of Packer's paw, a blimp ship decorated with shiny gears and clockworks appeared, and the two of them took off on a wild adventure to the Red Queen's castle. As they soared through the sky, Alice was amazed by the nature and streets of the steampunk world with its gleaming metal structures and intricate gears.
Tell me more.
Together, Alice and Packer faced countless adventures, from battling the minions of Queen of Hearts to freeing the King of Spades and the imprisoned cards. As they journeyed through the steampunk underworld, she discovered a world beyond her wildest dreams. After King of Spades rewarded Alice the key to her world, she felt a sense of bittersweet nostalgia, but she would never forget the lesson she learned about courage and friendship.
Now, before we move on, wanted to add one more thing that now not only did we add a voice as well as a face to this brain of large language models, we also equipped it a skill, which is query diffusion and create beautiful image that you have seen before you. And just before we end today's webinar, you will see exactly how we are able to do that, okay? So just to summarize, and we're not done, but just to summarize, because we talk about a lot of things now. So doesn't really matter where you start your journey, whether you want to use an API calls or in the playground with the already trained models, or you have already come to the conclusion that, hey, I'm going to train my own foundation models and I'm going to tweak it myself. Wherever your journey is, NVIDIA NeMo framework, again, it's open source, can meet you in every level. Okay. Now we are entering almost the last sections of today's webinar. So this section is specifically designed as the beginning of the journey. So again, nobody has the answers, like, you know, the holy grail answers. This is how you do it. No. We are at the beginning of this journey of trying to mitigate some of those known things that we know is the shortcomings of the large language models. I think they are not factual, they can hallucinate, and they can insist, hey, 10 is a prime number and argue with you, for example, this type of thing. Now we are going to see how we can have a tool, an open source tool, that help you tailor-made and control conversational flow according to your need. Introducing NeMo Guardrails. NeMo Guardrail is an open source framework. It's on GitHub. If you just type in NeMo Guardrail GitHub, and you will find it. It is purposefully designed to help you create and compose your own guardrail for your specific use cases. Now, consider this. If you are enterprise, a business, and you want to leverage generative AI technology, more specifically the large language models, even the almighty ChatGPT, but you still want to have a way to be able to manage the conversational flow just the way you want it to be, because you have a specific policy or you have a specific way you want things to be done. That's NeMo Guardrail. It helps you manage that conversation flow. Now, this is a little known fact, but NeMo Guardrail also allow you to equip your language model with additional skill sets, just like the one we have seen in the last demo, where you equip the language model with ability to query diffusion model to create beautiful images and make a story out of it, right? So we are going to take a look at first an HR use case as a demo of how NeMo Guardrail can help.
Now I'm going to show you a live demo. My colleague Chris Parisian, who's one of the developers who built this technology, is going to operate this demo, and I'll explain what you're seeing. So here we have a simple chatbot application that we've built on top of a large language model. We've connected this language model into a knowledge base. And so in this case, it's an application for answering questions about NVIDIA's HR benefits. And we've connected it to a knowledge base that has a lot of information about NVIDIA's HR benefits and policies. So we can ask it, what can you do? And it will tell us. As an AI, I can provide you with a wide range of services, such as answering your queries, offering guidance, providing relevant information about NVIDIA's benefits. So now let's ask it a benefits question. We are going to be adopting a child. Can I claim any of the adoption expenses? So this is a question that's a factual question. The guardrail system recognizes that this is a factual question. It allows the language model to look up the answer in this knowledge base, and then it provides fact checking on the result. And so here is a factual response from our knowledge base. Yes, NVIDIA offers an adoption assistance program, and then a number of details. Now let's ask it a question that would be inappropriate. So how many NVIDIANs adopted children last year? answering that question would require having access to confidential information. And so, first of all, this chatbot probably doesn't even have access to this information. And even if it did, we wouldn't want it to answer. And so in this case, NeMo Guardrails is actually detecting that this is an inappropriate question. It's asking for confidential information. And it's actually intercepting this question. It's never even passing it on to the language model for a response. So it detects, oh, I was asked a confidential question, and I'm just going to provide a canned response. And the language model isn't even involved. So I'm sorry, I'm not able to respond as that's confidential information. Now let's ask it a question that we know it doesn't have the answer to. Is there a support group for parents of adopted children? So this is a fact that we designed this application to ensure that this is not actually in the knowledge base we fed this language model. And so we want to detect it's a factual question. And regardless of the language model's response, it might hallucinate an answer, it might make up something plausible, but we're going to apply a fact-checking guardrail and detect a hallucination and ensure that the response is, I don't know. So that's what it says, right? I'm not sure. I recommend you talk to your HR representative.
Right, this all sounds a little bit like magic. So let's decipher a bit of how that works in a conceptual flow. Right, as we can see on the left-hand side, the user's query is, well, when is the film Titanic being made? Now, before we talk about this, you can see that here is a very interesting stuff that's get attached to the user query and sent into the large language model. That's instruction. So that means that this language model, if we're coming back to what we are having here, will be at least here already. So if the language model that is foundation models, then you have very little chance to success because you will not be following instructions. Yeah? Okay? So if you get a foundation model, so you need to check if you're using OpenAI ChatGPT models. That's great. It's already up here, right? But if you're using any open source community models, you need to double check where are they in this place so that you know that, hey, if I want to control the conversational flow, I at least need to make sure my model will follow instructions. Yeah? Okay. Right. Let's say we have a language model that follows instructions, and here is the instruction. Right? And this could easily be information that was like generic, right? But in this particular information that we wanted it to cite sources, and we actually plug in a Titanic information from Wikipedia. So this will generate, when it passes through the language model, NeMo Guardrail will ask the language model to generate intents from the user, and the intent from the user is ask about knowledge base. And this intent will trigger in a conversational flow in something called the colon file. Okay, it's also known called the canonical forms, and you can see it match this, so it would execute a skill called retrieving relevant chunks, the retrieval augmentation, with the plugin knowledge base to the language model. Okay, so inside there, as we have previously seen, once the intent is triggering the conversational flow, then you get to control it, because now it will say, okay, if I just let the language model run wild, it might be retrieving something from its training data, might not be up to date. However, if I equipped it with a knowledge base that's up to date, and in this case, it's a knowledge base tool set that I equipped the language model for. After the knowledge base respond with a factual correct answer, then the bot should also generate an intent and say, now I'm going to answer to your question, integrating this that you just gave me from the knowledge base you equipped me with, right? You can, of course, install further guardrails just in case something is not captured in the subflow. And in this particular case, no, it is not triggering any of the subsequent rails, guardrails. So it answers to your question, integrating the source, which is the local source, citing where I find this information, and gave you the correct answer from this knowledge base. Okay? Now, similarly, you can equip the language model with other skill set. Let's take a look at another one. This time, it's referring to a CSV file that you supply to the language model. Now, this time, the intent extracted is about data analysis. It triggers a column flow asking to do tabular data reasoning. So you equipped the language model with another model, which is expert in reasoning about CSV and or data frames. Okay? And then in this case, it doesn't trigger any additional rails, additional alarms in your guardrails. Then it responds with, according to the information of this particular file, this many people died, and cite of that particular place where it summarized the informations. By the way, this particular CSV file, I got it from Cargo, Titanic CSV. If you just type Cargo Titanic CSV, you'll find it. Okay. Two more. What about code generation? Well, we can do that too. So write the list into JSON files and save locally. So user intent, once again, being extracted is asked to generate code. This fall into an execution of using a skill set called code generation. And here is the code generated. Last but not least, remember we talk about the borrowing diffusion models capability. So here you say, generate an image of futuristic vehicle flying across the modern city, highly detailed, realistic. So the intent extracted this time is asked to generate image. It will activate the conversational flow and borrow the tools of image generation. In this case, it's a call to Hugging Face diffusion models, stable diffusion V1.5, if I remember correctly. And no additional guardrail is triggered. So it, in this time, it will tell you where to find this image that you saved to disk. And here's the image. Okay. Now, again, we talk about a lot of things. That's summarized one more time. So we talk about NeMo Service, which is serving foundation models in a variety of different ways: playground user interface, API call, customizations. We talk about BioNeMo Service and Picasso, which is our own way of serving foundational model in different modalities. It's gated by early access, so you do have to apply for. Now, if you want to use open sourced SDKs in order to get your own foundation model, or tweak it further to be instruction following, or push it to align to human preferences, then NeMo framework will be that framework that help you to not only do all these things, but to scale, and it is end-to-end. Okay, now doesn't really matter where you begin your journey, whether you just want to use an API call with the minimalistic customization, or you get to the point and say, I want to actually train and customize and deploy these things and make inference at scale. So NeMo framework can help you basically in all level of this journey. So that would be my summary of the day. Thank you very much for joining. I will now take questions.
Thank you for so good thank you for so good presentation, overview of NeMo and use cases. Yeah, if you have some questions, please ask them on our chat on YouTube. We will see your questions and we'll ask answer to them. I have one question about recommendation, for example, system and connect it to LLMs. I know that NVIDIA have Merlin framework, good framework for build recommendation system. If I want to connect this framework and solution which I built on it with NeMo, and have the chart which will work through LLMs and can get the data from Merlin. Is it possible to do? Have you some same cases?
Yes, in that case, I will probably will refer you to the demo that we have. It's called Project Tokyo. So basically, that particular project is specifically integrating large language model with recommender system. You probably have seen this demo that we did with this kind of eggy look-like thing in NVIDIA's headquarter office called Voyager. And that place, we have this egg looking like avatar that's taking your order of hamburger or French fries or whatever fries, salad, drinks, stuff like that. Yeah. And so that's a language model that's equipped with voice and face and then connecting to a recommender system in order to serve you, you know? Yeah.
Yeah, it's interesting solution. Will be interesting to know more details how it's built.
Yeah, it's hard to say it in such a short time, but if you're
Yeah, I
interested,
understand.
connect, then we will talk about it.
Yeah. Still don't have any questions. Okay, maybe more question. Maybe more technical question. What is different between inference for regular machine learning model and some LLMs?
Yeah. So machine learning models usually are quite small, right? They will probably not needing to even feed to one GPU, right? They are probably a lot smaller than that, like some hundreds of megabytes only. Now, these kind of large language models, for example, like the 175 billion GPT-3 model that we train internally using Megatron, again, another open source framework, that's now in NeMo framework. The checkpoint itself is like 1 point something terabytes. I mean, to serve this model at inference time, you must have multiple GPU or multi-node, right? And then chop this model into GPUs to serve it, right? Or that if you do quantization, like this kind of technique where they say, oh, I'm just going to use LoRa and then, insert some adapters and I'm going to quantize it. And then you have to kind of check if it has performance degradation, right? Because when you quantize it with precision, you almost always see some sort of performance degradations, right? So that's the difference between large language model versus the traditional machine learning type of model, right? Yeah.
Okay. Yeah. Thank you. Good. We don't have any questions. So thank you for this presentation and this overview. Thank you for all that you was with us. And see you next week on next webinar.
Bye, guys.